All right, in this next example, we're going to reflect a figure on a coordinate plane. So our first example, we have quadrilateral FGHJ. They gave us the coordinates for points F, G, H, and J. So we're going to go ahead and plot those points in our coordinate plane and label those. So F is 0, 3. So you have a 0 for your X. You're going to go up 3. Plot your point, label it F, that's point F. G is the point 2, 4, so you go 2 to the right and up 4. We're going to plot and label point G. H is 4, 2, so to the right 4, up 2, we've got H. And then J is negative 2, 0, to the left 2 and 0 up or down, so you don't go up or down at all, and that is point J. So this is a quadrilateral. Quadrilateral just means that our shape or our polygon has 4 sides. So I'm going to go ahead and connect those. There's 1 side, 2 sides, 3 sides, and our 4th side. Okay. So in part A, graph and label FGHJ. FGHJ, I don't know why this is hard for me to say, and this right here. So what this is telling us to do is we're going to do a reflection across the x-axis of our quadrilateral FGHJ. And then we're going to come up with a general rule for that. So let's go ahead and find our reflected points. So we're going to find F prime. We're going to do a reflection across the x-axis of point F, which is 0, 3. That's what we plotted. And now we're going to do that reflection across the x-axis. So here's our x-axis. What's kind of nice, I have to go to point F, I have to head toward the x-axis so that I'm perpendicular to it. So that is just going to be vertical right here. What I'm going to do is I'm going to count to see how far away am I from the x-axis. I'm 1, 2, 3 spaces away. Now I need to go on the other side that same distance. 1, 2, 3, and that's where F prime will be, the reflected point. I'm going to label it F prime. That ordered pair is 0, negative 3. All right, so we got F prime. Let's go ahead and find G prime. And we're going to work on our notation. So we're going to do a reflection across the x-axis of point G, which is 2, 4. Now let's go to our graph and figure out where G prime will be. So here's G. I'm going to head straight to the x-axis and count 1, 2, 3, 4. And now I have to go 4 on the other side. 1, 2, 3, 4. Plot our point right there. That's where G prime is going to be. And that ordered pair is 2, negative 4. All right, we've got F prime, G prime. Next we're going to do H prime. So H prime is a reflection across the x-axis of point H, which is 4, 2. So now I go to point H, I'm going to head straight to the x-axis and count 1, 2, and then I have to go 1, 2 on the other side, plot the point, label that's H prime. That ordered pair is 4, negative, 4, negative 2. All right, last we have J prime. J prime is going to be a reflection across the x-axis of point J, which is negative 2, 0. Now point J is on our reflection line of the x-axis right here. So there's nowhere for it to reflect because it's on the line. So J prime is going to be the same point as J. So negative 2, 0. So what do we notice about, oh, just kidding, let's not notice anything yet. We want to draw in our shape. So here's F prime to G prime, G prime to H prime, H prime to J prime, J prime to F prime. And we can see we've got a nice reflection of f, g, h, j across the x-axis, resulting in f prime, g prime, h prime, j prime. So let's write a general rule for this reflection we just did. When you take a reflection across the x-axis of any ordered pair x, y, it will result in, and let's see what happened over here. Here was our original point and here was our reflected point. So it went from 0, 3 to 0, negative 3. Here we went from 2, 4 to 2, negative 4. 4, 2 to 4, negative 2. And then this last one didn't change because we were on our line of reflection. So what you notice is the x's didn't change. So if you're reflecting across the x-axis, your x actually stays the same. But what does change is the y. All of these y values change signs. It went from a 4 to a negative 4, a 2 to a negative 2, a 3 to a negative 3. So the y is going to change signs. So we have a reflection across the x-axis of point xy will result in the ordered pair x, no change, negative y. Okay. Let's try another example. We need the same FG, the same quadrilateral. So I'm going to plot the same points. F was at 0, 3. I'm going to go ahead and label, well, maybe I should do this in red. I'll be consistent. So there's F, 0, 3. G is 2, 4. That's a G. H is 4, 2. And J is negative 2, 0. We'll go ahead and draw in our quadrilateral again for our second example. All right, so now they want us to take our quadrilateral and reflect it across the y-axis. So here's the y-axis, so every point is going to reflect across the y-axis. So let's figure out what our ordered pairs are going to be. Our reflected ordered pairs. We have f prime. So we're doing a reflection across the y-axis of point F, which is 0, 3. And then let's look. So 0, 3 is right here. It's on the y-axis, so that means that it has nowhere to reflect. That point will remain the same. So that means that F and F prime are the same point. And that's because F was on the reflection line. All right, so G prime, we're going to do a reflection across the y-axis of our point G, which is 2, 4. And now let's go ahead and do that reflection. So here's point G. Now we have to go to the y-axis because we're going to reflect to the other side. So I'm going to count 1, 2 spaces to the y-axis, and then I have to count 1, 2 spaces to the other side. And that's where G prime is going to be. That ordered pair is negative 2, positive 4. All right, next we're going to do H prime. That's a reflection across the y-axis of our H coordinate, which is 4, 2. So let's find H, and we're going to count to the y-axis, 1, 2, 3, 4. And then I have to go 4 spaces to the other side, 1, 2, 3, 4, and that's going to be H prime. H prime has the coordinates negative 4, negative 4, positive 2. All right, one more point to reflect. We're going to do J prime. We're going to do a reflection across the y-axis of point J, which is negative 2, 0. So point J is on the other side of the y-axis, but we're still going to count to it. So 1, 2 gets us to the y-axis, so we have to go 1, 2 on the other side to get J prime. So that ordered pair is 2, 0. We'll go ahead and draw in. Remember, F and F prime were the same. And then we'll go from G prime to H prime to J prime, and J prime back to F prime. So my red quadrilateral I can see was reflected across this symmetry line to get the blue quadrilateral. So what is a general rule for reflecting across the y-axis? If we're going to reflect across the y-axis, any ordered pair xy, and let's take a look at our ordered pairs. We went from 0, 3 to 0, 3. Well, that didn't change because point F was on the y-axis. But here we went from 2, 4 to negative 2, 4. 4, 2 to negative 4, 2. Negative 2, 0 to 2, 0. So the y value remained the same, but the x values all changed signs. So the rule is going to tell us that our resulting image will have a negative x, so we're going to change the sign of our x, but keep the y the same. Okay, don't you love long videos? This one was pretty hands-on though, right? So our concept, we're almost done with this video, reflecting points across the x and y axis. When any point P has the coordinates x, y, on the coordinate plane is reflected across the x-axis. So when you reflect across the x-axis, this image will be keep the x, change the sign of the y, so a negative y. When any point P with coordinates x, y on the coordinate plane is reflected across the y-axis, the image is you're going to keep the y, but you change the sign of your x. So there I am changing the sign of my x and keeping the y. Whew, all right, done with that example.